So 4.2 goes over something called logarithmic functions. These functions are also represented as log functions, so you're not necessarily going to hear the word logarithmic very often. It'll be more like log functions or log equations, that kind of thing. Important thing you know about this, which is something you should already know about, is your horizontal line test. Draw a horizontal line through any function. It should only touch once if it is a function. If not, then it's not. That is for your inverse of them, okay? With these functions or with these rules, you're going to see them in the form of y is equal to log a of x, or f of x is equal to log a of x. The log will be there. The a, the little subscript number, is your base. So that will be a number. And then the number after that is just the whole number part. So what it's practically saying is that base to what power is the big number. And you're going to find that power, and that would be your answer. We're going to focus the first part of this on going from exponential function to log form and vice versa. So going from exponential to log form, you are going to work clockwise with these. So what ends up happening is you're first going to write down the word log. Your base from the original expression or equation is going to become your subscript number, a little tiny number that's attached to log. Your answer becomes the power, and your big number becomes your answer. So like you're literally like working clockwise with these, okay? So for some examples that are done for us, if we have something like 2 to the third power is equal to 8, to put it into log form, we're going to put the word log there, drop that 2 down, the 3 becomes our answer, the 8 becomes our big number, so it's log 2 of 8 is equal to 3. Bless you. Then you have 2 to the fourth power is equal to 16, so drop the 2, log 2 of 16 is equal to 4. Again, you're dropping that base to be your subscript number, the answer becomes your big number, your power becomes your answer. For 2 to the power of 0 is equal to 1, drop the 2, the 0 becomes your answer, your 1 becomes your whole number. You have log 2 of 1 is equal to 0. Next, for 2 to the negative first power is equal to 1/2. Put the log in there, drop the 2, make the negative 1 your answer, the 1/2 your whole number. You have log 2 of 1/2 is equal to negative 1. Then with that, 2 to the power of k is equal to n. Log 2 of n is equal to k. With any of these, if you see on the top-ish kind of right-hand side here, you have log is equal to log 10. When there is no base, it's automatically assumed that the base is 10. Okay, so when there's not a base there, you're going to plug in a 10 for that little subscript number and treat it as the base. Okay, so for our first example, we are just writing these exponential forms into log form. So for a, you have 9 squared is equal to 81. We are going to drop down that 9. The 2 becomes your answer. The 81 becomes your whole number. Write the word log in there. So that's log 9 of 81 is equal to 2. You see here that the 9 is actually represented as a tiny number that's a subscript. So it's brought down a little bit and it's tiny. Your 81 and your 2 are regular, like whole numbers. So you need to make sure that when you give your answers for these, that's represented in the same way. For example, B, you have 3 cubed is equal to 27. So we're going to write down the word log, drop the 3, that's your base. The 3, that's your power, becomes your answer. The 27 becomes your whole number part. So that's log 3 of 27 is equal to 3. For example, C, you have x to the power of 0 is equal to 1, where x is not equal to 0. So again, we're going to drop down that x. Your 0 becomes your answer. Your 1 becomes your whole number part. Write down the word log first. So that's log x of 1 is equal to 0. For D, you have 6 to the power of 0 is equal to 1. So we're going to drop down that 6. The 0 becomes our answer. The 1 becomes our whole number. We have log 6 of 1 is equal to 0. For E, you have 8 to the power of negative 2/3 is equal to 1/4. That 8 drops down. The negative 2/3 is going to become your answer. The 1/4 is going to become your whole number part after your base. So you write down log 8 of 1/4 is equal to negative 2/3. For f, you have 5 to the power of 3/2 is equal to 5 times the square root of 5. The 5 as your base is going to drop down. The 3/2 is going to become your answer. And the 5 square root 5 becomes your whole number part. So you write down log 5 of 5 square root 5 is equal to 3/2. For the next part, we'll be working backwards with these, so we're going to be converting from log form to exponential form. With these, we're going to drop the log, bring up the base. Your whole number part becomes your answer becomes your power. So for something like log 10 of 100 is equal to 2, that's going to be 10 squared is equal to 100. For something like log 7 of 49 is equal to 2, drop your log. The 7 comes up, raise it to the second power is equal to 49. For something like log 8 of 0.125 is equal to negative 1. That gives you, to drop the log, 8 to the power of negative 1 is equal to 0.125. Then you have log 5 of 5 is equal to 1. That's 5 to the first power is equal to 5. And then log 12 of 1 is equal to 0, gives you 12 to the power of 0 is equal to 1. When these are given to you in log form and you turn them into exponential form, the result of it should give you a true statement. So it should make sense. It should give you a true statement. For these, you are going to think counterclockwise. So again, you're going to drop the base, drop the log. Your base becomes your whole number. Your answer becomes your power. And your big number becomes your answer. So for example 2a, we have log 10 of 10 is equal to 1. We're writing the log form in exponential form. So this is going to drop the log, bring up the 10. Your 10, that's your whole number, becomes your answer. The 1 becomes your power. So that gives you 10 to the first power is equal to 10. For example B, you have log 12 of 144 is equal to 2. We're going to drop the log, bring up the 12. 2 as your answer becomes your power. The 144 becomes your answer. So that's 12 squared is equal to 144. For example C, you have log 1/2 of 8 is equal to negative 3. So we're going to drop the log, bring up the 1/2. Make the negative 3 the power, the 8 your answer. So that's going to give you 1/2 to the power of negative 3 is equal to 8. For example D, you have log 6 of 36 is equal to 2. We drop the log, bring up 6, make the 2 our power, make 36 our answer. So that's 6 squared is equal to 36. For E, we have log 2 of 2 is equal to 1. So drop your log, bring up the 2 as your base, raise this to the first power, bring the 2 as your whole number to your answer. So that's 2 to the first power is equal to 2. For F, we have log of 0.001 is equal to negative 3. This one doesn't have a base, so it's understood that the base is 10. We drop the log, bring up the base of 10, raise it to the negative third power, set it equal to the 0.001. So that gives us 10 to the negative third power is equal to 0.001. So with this example, when you're evaluating logs, you are looking at the power that your base is being raised to give you your big number. So if we look at these examples, you're going to plug in the x value for x, and then ask yourself that little subscript number raised to what power is the big number. That power is your answer. So if for A, you have f of x is equal to log 2 of x. We're using x is equal to 32. So that means that, I'm going to do it over here. We have log 2 of 32. So that's 2 to what power is 32? we ask ourselves, 2 is raised to what power? That power is our answer. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2, which would be 2 to the 5th power, is 32. So 2 to the 5th power is 32. That power of 5 is your answer. For example, B, you have f of x is equal to log 3 of x, where x is 1. So that means you have log 3 of 1. So rewrite it to where it's 3 to what power is equal to 1? Well, anything to the power of 0 is 1, so that's 3 to the power of 0 is equal to 1. So that 0 is your answer. For example, C, you have f of x is equal to log 4 of x, and x is equal to 2. So if we rewrite this with the 2 in, we have log 4 of 2. So that turns into 4 to what power is 2? Well, if we take the square root of 4, that's going to give us 2. The radical or the square root is represented with the power of 1/2 because you have the index of 2 and it's raised to the first power. Bless you. So that gives you the 4 to the 1/2 power is equal to 2. So your power is your answer. So 1/2 is our answer for example C. For example D, we have f of x is equal to log 10 of x. Remember, if there was not a base on this, it would be 10. Our x in this case is going to be 1 over 100. So that's going to give us log 10 of 1 over 100. So that means it's 10 to what power is equal to 1 over 100? Well, in order to take the reciprocal of 10, it would have to be a negative power, and 10 squared is 100. So that means it's 10 to the negative second is equal to 1 over 100. So that negative 2 is your answer for example D. For our next part, we're going to look at different properties with these logs. When you work with logs, you also are going to work with something called a natural log, which is just ln. On your calculators from 4.1, we use this shift button or the second button and then the ln button to give us e to the power of x or e to the power of something. The natural log or the ln is just another form of your logs. You have certain properties with your logs that cancel out your base or your log or your power with these. So some of them that you see here, if you have log of a base of 1, it's always going to be equal to 0. So log of anything of 1 is always 0. If your base is the same as your big number, it's always going to be equal to 1. So something like log a of a, it would have the same base and the same big number, it's equal to 1. Anytime you have a power on your big number, that power is going to move to the front of your log with multiplication. So if you have something like log a of a to the power of x, that x is going to move to the front. The log a of a cancels out, so it would just be x. Then for that last one, if you have something like log a of x is equal to log a of y, that means that your big numbers are equal to one another. So if we look at examples that go with these properties, for example, A, you have log 2 of x is equal to log 2 of 3. Your base on here is the same, so they would cancel out, and you would just have that x is equal to 3. For example, B, you have log 4 of 4 is equal to x. Your base and your whole number part are the same, so they cancel each other out to be x is equal to 1. For example, C, you have log 5 of 5 to the power of x. Your power on this 5 is going to go to the front to give you x times log 5 of 5. Your base is the same as your whole number part, so they cancel each other out. So this just leaves you with x. For example, D, you have 7 to the power of log 7 of 14. For this one, your base and your power have the same base, so they cancel out, and you're just left with the 14. So the last sections within your notes go over natural logs and e. Your natural log is just given to you as ln. You will also see e to the power of x within these functions. With these natural logs, you are using the button in your calculator to evaluate them. You're going to be given the value for x. You plug in the L, or you hit the ln on your calculator, then the number in for x, and then you work with it that way, give your answer. We're going to be rounding to 3 decimal points with this. So if we look at the first example for A, you are going to have ln to the power, or sorry, ln times x, x is equal to 2, so that's ln of 2. So again, just plug that into your calculator, round to 3 decimal places, you should get 0.693. For example B, you have x is equal to 0.3, so you're going to do the natural log of 0.3. Again, just type in the ln, then 0.3, close the parentheses on your calculator, round to 3 decimal places, you should get negative 1.204. For B, you have the natural log of x, where x is equal to negative 1. So for this one, you're going to get the natural log of negative 1. Now, you cannot take the natural log of a negative number. So if you were to plug this into your calculator, it would tell you that there's an error, and I think it's a domain error. So whenever it gives you that, or you realize you can't take the natural log of a negative number, you just write no solution. Because again, you cannot take the natural log of a negative number. For example D, you have the natural log of x, where x is equal to 1 plus the square root of 2. Now, depending on the calculator that you have, you may have to do the square root of 2 first, hit enter, add 1 to that number, and then do the ln second answer. So that way it gives you whatever that is. In the calculator that I use, that TI30XS, you can literally plug it in exactly how you see how I'm going to write it. So for this written down, it would be the natural log of 1 plus the square root of 2. Again, in my calculator, I can just type this in. If I round to 3 decimal places, I get 0.881. So the last part we're going to look at goes over your properties of your natural logs. If you have the ln of 1, it's always going to be 0, just like e to the power of 0 is equal to ln. ln times e, it's always 1. They cancel each other out. They're inverses of one another, so they cancel each other out. Just like e to the power of 1 is e. ln times e to the power of x, they cancel each other out, so the only thing you're left with is that power, so it would be equal to x. Same thing if e was raised to the power of ln of x. The e cancels out the ln. The only thing that you're left with is x. Lastly, if you have ln of x is equal to ln of y, the ln's cancel, just like if it was log of x times is equal to log of y. They are the same on both sides, so they cancel out. You're just left with x is equal to y. So we're going to use those to simplify these 4 examples. For A, you have the natural log of 1 over e. Well, 1 over e is the same exact thing as saying the natural log of e to the negative first power. So we said that the natural log and e cancel each other out, so you're just left with negative 1. For B, you have e to the power of ln of 5. So your e and your natural log cancel each other out, and you're just left with 5 for this one. For C, we have 4 times the natural log of 1. Well, the natural log of 1 is just 0, so that's 4 times 0, which is 0. For your last one, you have 2 times the natural log of e. The natural log times e cancels each other out, and it's equal to 1. So that's just 2 times 1, which is 2.